Okay, we're in the final week year. Looks like Grace is online today. Um, so what are we going to do this final week? Mainly we're going to be working on the final project. I'll do spend about I think half an hour this morning doing a review and talking about how you could be using this course and looking, kind of wrapping up this course and how you could use it in the future here. And we'll make sure we're all on the same page with the final project and presentation for that. And we'll give you some time. Maybe you want to do the course evaluation. There's a link in here for the course evaluation here. Especially with a new course like this, course evaluations are quite helpful to give us some feedback on how the course is. And again, feel free just to let me know if your thoughts after this course, if you think something should change or whatever, since it's the new course, is a good time to have some input on this here. This has been an interesting course, teaching it in a hybrid format. Um, we've had, we've got about 15 students in the course. And I think about a third of you have been consistently coming to class. And about a third of you are on campus but haven't been coming to class. And about a third of you are remote students there. So it's been an interesting mix here. But all of you have been doing amazingly well at staying active and participating in the class there. This is especially for a new class, this is one of my best classes as far as people turning in assignments. I think I've had a fair amount of assignments and stuff due. And I think 14 of the 15 students turned in nearly every assignment there, or everything that's out there. I've got one student who's fallen behind these last couple of weeks, but I I have faith that student's going to catch up in the next week or so for this. But I have been impressed with everyone being active in this course and participating and submitting stuff. So it's been interesting, even though we haven't had sometimes that many students here in class. Seems like a lot of people have been working in the discussions and doing the work. We've been doing these shared activities. I'd really be interested to hear how people liked, or disliked possibly those shared activities that we do every Thursday for that. But again, those have been doing quite well also. So, okay. So yeah, do the course evaluation if you can here. Also sign up for a presentation time for the final project. Let's just talk a little bit about the final project and the presentation time. So you can sign up for a presentation time. I did make a mistake. It was pointed out to me on the exam time. Here, our final exam time is not Monday, it is Tuesday here. And so that's it. So Allie and Hiva, make sure, I'll try to talk to you, but make sure you realize that it's not Monday, but Tuesday there. And it's supposed to go from 9 to 10. I mean, 8 to 10. I think we'll just start at 9. I'm just going to put it down. So we'll just start between 9 and 10 o'clock. We should be able to get enough people. If too many people sign up, right now we have 4 people signed up. That's at most 40 minutes of work there. So that should be fine there. So for now, we'll do that starting at 9 here. And you can choose one of these presentation times. So sign up for a presentation time here. Okay, let's see. And then let's just talk a little bit, since we're talking about the final project, when things are due here. Interesting. There. Okay. So remember, it's a 2-part process for the final project. You have to write a paper here. I have the paper due this Sunday, May 4th, because we've been doing Sunday due dates here. So I have the paper due this Sunday. Here, if again, it's hard for me to kind of, and all of our faculty are doing the same time, trying to figure out how to schedule these so that you don't have all your projects and papers due on the exact same day here. So in this class, I'm pushing it early, so it's on Sunday. If you have a bunch of stuff due this week and not next week, let me know. I can give you an individual extension on this. But right now, unless you ask, the paper will be due this Sunday. And then the presentations are next week. I put May 8th. That's the last time, you can sign up to present. But again, you can sign up for any of the 4 presentations. You have to do this presentation synchronously, even the online remote students. You can't do a recorded presentation. So you have to do it on Zoom with me there or with live, in person here at either the final exam time or the other time. What was the other time? The exam time or the last day of class. So yeah, next Thursday, we'll have an opportunity to do presentation. So in 2 days, you can present then also here. And again, the reason for that is that I want to be able to ask you questions. So idea is you do a 5-minute presentation and you do 5 minutes of questions here. I will grill you to make sure you just didn't type this into AI, but actually know something about what you're presenting on here. So I'll grill you with questions like, what surprised you most from this research? Or which of your source materials did you use the most there? So you'll have fun, exciting questions like that you'll have to respond to. And again, student question, I'm sure your peers will be asking exciting questions also if they're there. Okay, so that is the presentations and presentation times and then the paper. Any questions on that? Okay, let's go back into unit 15 here and do a quick kind of walkthrough of this class. So again, this has been an interesting course. This is a new course. I've never taught a course exactly like this. It is very similar to 2 other courses that are often taught, a programming languages course, where you look at a variety of programming languages and techniques in those different programming languages. Then you look at functional programming languages and logical programming languages, and imperative languages, these object-oriented languages, and you look at the different structures of it. So, and then that's one, and the other one is just a computational theory course where you spend the whole course looking at Turing machines, grammars, languages, like those formal languages, not necessarily programming languages there. And again, P and NP and complexity theory and stuff like that. So, so we've kind of, bridged that gap. We started off looking at kind of formal syntax, Bacchus-Naur form, how we kind of define a language here. And that helped us actually build lexical parsers and how you could create a computer program that would parse a code for that. And we looked at some ways of doing this. Then we turned a little more formal to this formal language theory, deterministic finite automata, regular expressions, things like that. Push down automata we started getting into there. But we saved some of that for later, actually. So that was kind of more theory like. And then we worked, moved what I would say into traditional programming languages course, where we went over, names and identifiers, variables, how we do type checking, how we declare things. We talked about how we declare functions here and what a functions are. We talked about data structures and objects for this. We talked about memory management, garbage collection stuff. And then we turned to Turing machines and proof of undecidability, and then this complexity theory with big O notation and then NP complete prompts. So again, the last few chapters were again returning to this theory stuff here. So I see this as being, if you're in this course, you're either a software development major concentration, or maybe you're in computer science and want to go to grad school there. So I've tried to set this up so it helps you both. So, I mean, takeaways I look at for software developers. One thing I hopefully you gain from this course is to see patterns or see code in different languages. We've tried to look at the same kind of problem in 2 or 3 different languages there, and then also look at a variety of languages. Kind of the goal here is to get you to a point where you're not seeing the language, you're seeing the concepts behind the language. A lot of times we talk about when you're doing software development and that sort of stuff, that at some point you're kind of looking behind the language to the underlying structure of this. So that, and in that way, when you learn a new language, it's not that hard, because again, you're just overlaying it onto these software structures that are underneath these language ideas here. So one thing you might want to consider is we didn't do a lot of programming here, but if there are programs examples in some of the languages that you don't have in your resume anywhere, you might want to consider looking back at some of the bigger kind of programs or code that you worked on and worked with, and maybe sharing that on GitHub. In GitHub, again, it shows what languages every project is, and so sometimes it's nice just to have samples or code examples from classes in a number of different languages, especially if you're saying on your resume that you have had some experience with those languages here. So besides seeing different languages, we've kind of tried to understand these core concepts, scope, parameter passing, those sorts of memory management, those sorts of we tried to do a little better dive into those sorts of ideas for that. We also looked at some of the different paradigms like functional programming languages, and one of the things I see now is that we're bringing a lot of that functional stuff over into our interpretive languages here with some of the new patterns like the map function, stuff like that. Again, so that's if you're going to be a software developer. If you're thinking about grad school, I think the goal of this is to try to set you up for grad school a little better. You'll probably have to take a computational theory class in grad school. You may have to take a programming language class in grad school. It kind of depends on the grad school, but in a lot of PhD programs, if they're just traditional computer science programs, the first 2 years are all courses, and they're kind of advanced, some of the advanced versions of some of the courses you may have taken as an undergrad here. So hopefully it'll set you up so that if you are taking a computational theory course in grad school, you have some of the background needed for that. Also gives you some kind of hopefully understanding that there are people who just study this theoretical computer science as a field, and you can go into that. But no, I think 90% of the people going into computer science PhD programs are studying AI, but there are still jobs and people going in and studying other fields. Not everything is AI today. So I'm hoping most of you have a final project idea here. If not, I want to share this. One thing I did do that you may want to use, and I added you to this, is I put a bunch of our notes and prompts and stuff like that from the class into this notebook LM system that you can ask them questions of it. So if you're trying to get some ideas and not, you can certainly just use AI in general, but you can certainly use that system. Uh, but remember, you have three different types of research projects that just the typical research paper here. So like one that I would do if I was a student, I would do this advanced complexity classes beyond P and NP here. What are some of the other complexity classes for this? The other thing is advanced programming tutorials. That's your other option here. One thing, and I was kind of thinking of, and what are some things I do? One thing I would like to look at is that I'm seeing a lot, we're using AI a lot to do this. And my thought is that AI has a strong preference to certain patterns, certain way of coding here. And so I think it's important to understand what the way AI prefers to code so that you can better use it there and realize that it has, a lot of AI coding models have kind of some default, I almost say biased to doing things certain ways. And they're often, sometimes there are ways that I don't want it to do. So I sometimes have to almost countermand it to say, don't do it this way, do it this way here. So that would be one place you could look at is some of advanced programming, how to better use AI for this. Another area I find interesting is Lambda functions. I go back and forth, like when we do our next fall, we'll do the mobile apps course, and we use Lambda function all the time because, again, we use Lambda functions for all of our button clicks and stuff like that. So a lot of the interaction is all done with Lambda functions these days. It's kind of a standard process. And I actually find it more confusing to read the code that way. But again, we teach it that way because it's kind of the standard way of doing this when you do Android programming for that. But I sometimes think Lambda use functions are overused and make the code a little harder to understand rather than easier to understand for this. Sometimes I think it's useful just to actually declare the function, give it a name, so you know what it is, and then just call that function by name rather than use a Lambda expression. Again, you can look at some of these programming techniques or research some new programming language out there. Since I've been talking a little bit about AI, I wanted to jump one more thing here. And that is just talk about AI in the final project. So I added some guides to AI use here with writing this research paper for this. And so remember to use, that writing this research paper is supposed to be part of your learning. And you should be able to choose a topic that you want to learn about, and you should be learning it. And so you should be using this writing and AI to aid you in that learning process. You certainly don't want to use AI to do the whole thing so you don't learn, I guess, is what I'm saying. But again, don't be afraid. I think AI is a powerful tool for this. You just have to be careful where you want to use AI for this. So again, for some of this stuff, doing your preliminary research is good. And even when you start finding sources and reading through those, I think AI is really helpful at explaining parts of a paper or helping you understand why a paper is significant or stuff. In grad school, it's really common when you're doing these research papers, there's often like a Thursday night forum where every Thursday a group of students are assigned a paper and they just present on that paper. They're saying you get up and you explain, you walk through some paper out there and explain how you what you understand from this paper there. And again, and often when you're working with other grad students on understanding things, you'll sit around and talk about a research paper and say, oh, you know, what did you understand this equation, or what were they trying to show in this graph, or why were they saying this stuff? Because a lot of times the writing in research papers is very condensed. So a lot of information can be put in just a graph or an equation or something like that. What I find AI helpful is that it can help you kind of in that same way. While you're reading through the paper, it can help you serve as your partner and give you some help when you get stuck or you need something explained. So I think that's very helpful here. The other thing is, I think it's very helpful once you've written your paper to go back and edit it here. It's hard, I know, with AI, you know, how to use it. Like, just for example, I was using AI to help generate these lists here. These sorts of lists here, like paper ideas and stuff like that. I think it really helped me brainstorm some of these ideas here and get them down relatively quickly. But again, I then went through and edited them. So like this, you know, I think they had 3 sentences of description here, and I didn't want that. But I rewrote it as 1 sentence. But having it down here, I edited a lot of these, and I changed stuff. So there was stuff here that, like this lambda functions, they had something else here, but I really wanted to talk about lambda functions here, so I added that in. This and this were ones that were, you know, basically exactly what I would have put down here anyway. So I left those. So again, when you're working with AI and writing, be careful to, you know, I guess one thing I want to say is there are times where you can just use AI to generate something and send off. If it's not important, just use AI to write something there. So if there's some paperwork or something, an email I have to send, and it's not that important to anyone, I'll just use AI to do it and send it off. Then I will read it, but won't even edit it generally. But there are places where things are more important where you don't want to do that. And so this is, in my mind, something that's more important. So you should be writing it and then using AI as a partner in having it proofread it and make suggestions to it for that. So, and that, I mean, one of the important parts of this is to have you learn something for that. So, okay, so enough Tom's lecturing on how to use AI effectively, I think. Okay, so I'm actually going to, I think, wrap up for the day, give you time. So if you're not done with your paper, you can be working on it. If you have questions, you need help with it. We don't have anything else due this week. I figure at this time you have enough other stuff in other classes too, and you've got this paper to work on. So that's all we're going to do, and I'm not going to take up any more of your time talking about it. So feel free to keep working on your paper. If you're done with it, that's fine. And I'm looking forward to the presentations next week. I'm good. Any questions? All right.